Look up at the night sky and you might catch a glimpse of shimmering auroras, nature's own light show. These ethereal lights dancing across the heavens captivate our imagination and remind us of the beauty and mystery of the universe. These dazzling displays are a beautiful reminder of a powerful force at play: our sun. The sun, a massive ball of burning gas, is the heart of our solar system, providing the energy that sustains life on Earth. While the sun sustains life on Earth, it also unleashes bursts of energy known as solar storms. These storms are caused by the sun's magnetic field lines snapping and reconnecting, releasing immense amounts of energy. These events, though visually stunning, have the potential to disrupt our technology-dependent world. Solar storms can interfere with satellite communications, power grids, and even the navigation systems we rely on daily. Understanding solar storms is not just an academic pursuit, it's about safeguarding our way of life. Scientists around the world are constantly monitoring solar activity to predict and mitigate the effects of these powerful events. Imagine a world without electricity, where the lights go out and the hum of modern life comes to a halt. The impact of a severe solar storm could be catastrophic, affecting everything from our homes to our hospitals. GPS, which we use for everything from navigation to timing, could be rendered useless. The precision and reliability we take for granted could be lost in an instant. Air travel, too, could be severely disrupted. Planes rely on sophisticated technology to navigate and communicate, and a solar storm could ground flights, causing chaos and confusion. These storms are a stark reminder of our planet's delicate balance and the power of the star we orbit. The auroras, while beautiful, are a sign of the immense energy being released by the sun. As we venture further into space and rely more heavily on technology, understanding and preparing for solar storms becomes increasingly crucial. Astronauts aboard the International Space Station must take precautions to protect themselves from the harmful effects of solar radiation. The sun, our nearest star, is not a static ball of fire. It's a dynamic and complex object, constantly undergoing changes that influence our planet in profound ways. Solar flares and magnetic activity are just a few of the phenomena that scientists study to understand the sun's behavior. It's a dynamic and complex object, constantly undergoing changes that influence our planet in profound ways. By observing the sun's surface, we can learn about the processes that drive these changes and their potential impact on Earth. By understanding these changes, we can better predict and prepare for the challenges posed by solar storms. Researchers are developing new models and technologies to forecast solar activity and protect our planet from its effects. The sun, like many things in nature, has its seasons. These seasons are not marked by changes in weather or temperature, but by the intensity of solar activity. But unlike Earth's yearly cycle, the sun's activity waxes and wanes over an 11-year period, known as the solar cycle. This cycle is a fascinating dance of magnetic forces and plasma flows. During solar maximum, the sun is a hotbed of activity, with sunspots, solar flares, and coronal mass ejections occurring more frequently. These phenomena can release vast amounts of energy and charged particles into space. Solar minimum, on the other hand, is a period of relative calm. The sun's surface appears more tranquil, with fewer sunspots and less frequent solar flares.
Imagine a pot of boiling water. The vigorous bubbling and steam are akin to the sun's activity during solar maximum. During solar maximum, the sun is like that pot at a rolling boil, with energy bubbling to the surface. The intense heat and activity are unmistakable. Solar minimum is like the pot simmering still hot but with less intense activity. The surface is calmer, but the underlying energy remains. This ebb and flow of solar activity is driven by the sun's magnetic field, a complex and constantly shifting force. The magnetic field lines twist and tangle, influencing the sun's behavior.
This 11-year cycle is not just a celestial curiosity, it directly impacts the frequency and intensity of solar storms that reach Earth. These storms can disrupt communications, navigation systems, and even power grids. Understanding this cycle helps scientists predict when we're most likely to experience the sun's wrath. By studying the patterns, they can forecast periods of heightened solar activity. Just as we prepare for hurricane season on Earth, we must also be ready for the sun's stormy seasons. This preparation involves safeguarding our technology and infrastructure against potential solar storm damage. Scientists continuously monitor the sun using telescopes and satellites, keeping a vigilant eye on its behavior. Their observations are crucial for predicting and mitigating the effects of solar storms. Understanding the solar cycle is also vital for future space missions. Astronauts and spacecraft are vulnerable to solar radiation, and knowing when solar activity will peak can help ensure their safety. The Sun and Earth are deeply interconnected, and studying the solar cycle helps us appreciate this relationship. By understanding the Sun's rhythms, we can better prepare for its impact on our planet. Among the many solar events, coronal mass ejections or CMEs are the most concerning for Earth. These massive bursts of solar wind and magnetic fields can have far-reaching effects on our planet. Imagine 1 billion tons of superheated gas, a fiery cloud of plasma, erupting from the sun's surface at millions of miles per hour. That's a CME. These colossal eruptions can travel through space, carrying with them a significant amount of energy. These eruptions are triggered by the sun's tangled magnetic fields, which can snap and realign, releasing tremendous energy. The sun's magnetic field is incredibly complex and dynamic, constantly shifting and changing.
Think of a rubber band being twisted and twisted. The more you twist it, the more tension builds up. Eventually it snaps, releasing all that stored energy in an instant. This is similar to the process that occurs with CMEs. That's similar to what happens with CMEs. The magnetic fields on the sun can become so twisted and stressed that they eventually snap, unleashing a powerful burst of energy. When these magnetic fields snap, they launch a CME into space. This burst of energy and plasma can travel across the solar system, sometimes reaching Earth.
If Earth happens to be in the path of this solar storm, the consequences can be significant. The interaction between the CME and Earth's magnetic field can lead to a variety of effects. While not all CMEs are aimed at Earth, those that are can interact with our planet's magnetic field, triggering a cascade of effects. This interaction can cause geomagnetic storms, which can have both beautiful and disruptive consequences. These effects can range from harmless auroral displays, which light up the sky with stunning colors, to disruptions of our power grids and communication systems. In severe cases, CMEs can even damage satellites and other space-based technology. Understanding CMEs is crucial for mitigating their potential impact on our technology-dependent world. Scientists are constantly studying these solar events to better predict their occurrence and develop strategies to protect our infrastructure. By improving our understanding of CMEs, we can better prepare for and respond to these powerful solar storms. When a CME collides with Earth's magnetic field, it can induce powerful electric currents in our planet's upper atmosphere. These currents can then flow through power grids, overloading transformers and causing widespread blackouts. In 1989, a solar storm caused a major blackout in Quebec, Canada, leaving millions without power for hours.
Imagine a city plunged into darkness, traffic lights out, businesses closed, and communication systems down. That's the potential impact of a severe solar storm on our power grids. But it's not just our power systems at risk. Satellites orbiting high above Earth are also vulnerable.
CMEs can damage sensitive electronics on satellites, disrupting GPS navigation, communication networks, and even weather forecasting.
Astronauts working outside the protective shield of Earth's atmosphere are also at risk from the radiation released during a solar storm. Understanding these risks is the first step in developing strategies to protect our technology and those who rely on it.
In recent years, we've had several close calls with solar storms. In 2012, a CME estimated to be the most powerful in over 150 years narrowly missed Earth. Had it hit, the consequences could have been catastrophic. These near misses serve as a stark reminder of our vulnerability to solar events.
The National Oceanic and Atmospheric Administration, or NOAA, constantly monitors the sun for signs of potential storms. They issue space weather forecasts, much like weather forecasts on Earth, warning of potential solar activity. These forecasts are crucial for giving us time to prepare for the sun's next move. These warnings are not meant to scare us, but to prepare us. Just as we take shelter during a hurricane, we can take steps to mitigate the impact of solar storms. By heeding these warnings and taking appropriate action, we can weather the solar storm. Recognizing the threat posed by solar storms, governments and organizations worldwide are taking steps to improve our preparedness. In 2020, the United States Congress passed the Pro-SWIFT Act, which aims to enhance space weather forecasting and improve coordination among government agencies. Imagine a network of satellites, constantly monitoring the sun, providing real-time data on solar activity. That's one of the goals of the Pro-Swift Act. This legislation recognizes that space weather is not just a scientific curiosity, it's a national security issue.
But it's not just about government action. Power companies are hardening their grids, making them more resilient to solar storms. Satellite operators are developing strategies to protect their spacecraft. By working together, we can create a more resilient world, ready to face the challenges of space weather.
During a solar storm, different sectors take specific measures to minimize disruption.
Air traffic controllers may reroute flights to avoid polar regions, where radiation exposure is highest. Railway companies may reduce train speeds to prevent potential signal malfunctions caused by geomagnetic interference. Imagine a ballet of coordination, with different industries working in sync to minimize the impact of a solar storm. That's the level of preparedness we need to strive for.
From airlines to power grids, every sector has a role to play in building a more resilient world. These strategies are not just about protecting infrastructure, they're about protecting people. By taking these precautions, we can ensure the safety of airline passengers, train travelers, and everyone who relies on our technological infrastructure. Improving our ability to predict space weather is crucial for mitigating the risks posed by solar storms. Scientists are constantly working to develop more accurate models of the sun's behavior, allowing us to forecast solar events with greater precision. Imagine a future where we receive personalized space weather alerts, telling us exactly how a solar storm might impact our region. This is the future of space weather forecasting, a future where we are not just reacting to solar storms, but anticipating and preparing for them. The sun, our life-giving star, is also a source of potential danger. By understanding solar storms, preparing for their impacts, and improving our ability to predict them, we can harness the sun's power while safeguarding our technological world. The future belongs to those who can not only reach for the stars, but also weather the storms they may bring.